Good morning, teachers, and welcome to another episode of Experiments with the ScienceBus. Today, we shall be thoroughly exploring the study of the acoustics kit, and more specifically, we will be focusing on one of the most fascinating characteristics of the propagation of sound waves, which is referred to as resonance. For this particular experiment, we shall require two resonance boxes with tuning forks securely mounted on top, a wooden rod, and a small weight, all of which are consistently found within our kit. Through conducting this particular experiment, we aim to assist our students in comprehending how, by striking the initial tuning fork, which is referred to as the resonator, the sound waves that are emitted by it will propagate through the resonance boxes and the air contained within them. Consequently, the second tuning fork will begin to sound sympathetically, precisely because the second tuning fork also vibrates at a frequency of 440 Hz, exactly like the first one. Now, let us carefully take the two resonance boxes and position them in very close proximity to each other, ensuring they are no more than 1 to 2 centimeters apart at the openings. Subsequently, strike the initial tuning fork with considerable force. Let us silence it. And we will hear that the second tuning fork has started to sound solely due to the action of the first. To convincingly persuade the students regarding this intriguing phenomenon, we can conduct a concise experiment by affixing a diminutive weight to one of the two tuning forks. We attach this weight to one of the prongs of the two tuning forks, and now we will observe that if I strike the first tuning fork and subsequently silence it, the other one does not commence to sound. This occurs precisely because I have altered the frequency at which the second tuning fork vibrates. So the sound waves emitted by the first are not sufficient to set the other tuning fork into vibration. Today we explored one of the most fascinating characteristics of the propagation of sound waves, namely how a tuning fork set into vibration can cause another tuning fork to sound on its own, solely through the propagation of sound waves in the air. This is an exceptionally fascinating experience for individual students to attempt one by one, allowing them to experience it directly. In upcoming videos, we will continue to explore other characteristics of the propagation of mechanical and acoustic waves, so please keep following us here at Experiments with the ScienceBus of Wacebo.